So we've just talked about validation using energy, and that's certainly one useful application of energy. A second useful application of energy is actually one that relates to conservation more generally, which has to do with this sort of idea that you can use conservation either to do sort of continuous modeling. So you can ask questions like, how is the energy changing in time, or how is the momentum changing in time? So when you write dp by dt is the sum of forces, right? You're actually writing a continuous differential equation, and you're saying things about how the energy is changing in time continuously. But as we've talked about previously, you can also do sort of before and after modeling using conservation. And we've done that for momentum, but you can actually do that with momentum. You can do that with angular momentum, and you can also do that with energy. And it's often the case that by combining momentum, angular momentum, and energy together, you can actually say some pretty interesting things about events in a system, even if you can't say the details of what the event are. So, for example, a sort of classic example that I certainly ask you to think about in the homework is if you think about a pool ball that's traveling along and it interacts with some other pool ball. So this is the sort of before instance, right? One pool ball is traveling, the other pool ball is sitting still. If I think about after, there's some event here that happens. That is, the pool balls hit each other. And then after the event, one pool ball is traveling in one direction, one pool ball is traveling in the other direction. And you'd ask the question, what's the, given the initial conditions, and given what you know about this event, what's the final condition? And the reason why these sort of conservation ideas are useful is that depending on the types of interactions that are present in the system, you can often say things like, oh, this is an interaction, whatever this event is, it's an interaction that does not change what the total angular momentum in the system is. So there's no flow of angular momentum into or out of the system. Or whatever the nature of this interaction is, it doesn't change what the total energy of the system is. So it's what you would call, in the case of a collision, it's what you would call an elastic collision. In the case of some other kind of interaction, it's a conservative interaction. Or that there's no momentum flow into or out of the system during this event. So it's an event that conserves momentum. So this is sort of a general idea. It's one that applies to an awful lot of situations. It's usually used for talking about collisions, but certainly you can use it for a lot of other cases where you don't actually want to figure out what's going on continuously, but instead you want to figure out what the final condition is given some initial conditions. And in the next couple of videos, we'll just do some simple examples of this.